Hello everyone, welcome to the next lecture on the Mobius transformation. Today I will explain you the most important topics under the complex analysis is cross ratio. Myself Dr. Harish Garg, you can follow and subscribe my YouTube channel. Now what we have discussed so far, we have learned the concept of the complex linear transformations which are defined as a map AZ plus B. Under this map we have learned the concept that the mapping T, it maps lines to the lines and the circle to the circle. However, the complex linear transformation does not map the circle, like if this is my circle and under the transformation it is a line. Fine. So whenever there is a complex linear transformation, the circle map to the circle, line map to the line, but we are always interesting to find which are bounded by the circle onto the line. For example, if this is my circle and my target is to find the mapping into the straight line, the question arises is how we can define such a map. How we can define such a map? The answer is the Mobius transformation is a well suitable for such kind of the application. But the most important question arises is how we can define such transformation. In order to define such transformation, we need the idea of the cross ratio. So we can construct the bilinear transformations based on the cross ratio. And the today's objective is we will learn what is the concept of the cross ratio and how we can define the mapping based on the cross ratio. And my objective is once I will complete my lecture, you are easily to solve all these 6 examples as an exercise. You can note down this exercise on your copy. Once I will complete the lecture, you can see how you can solve these questions in your copy. You can put your answers in the comment box so that you can verify whether your answer is correct or wrong. Now, what is the cross ratio? So in order to define the cross ratio, you always need the 4 complex numbers: Z, Z1, Z2 and Z3. And how you can remember these numbers? If you have the 4 numbers Z, Z1, Z2 and Z3, fine. How you can define the cross ratio? You can find Z minus Z1 divided by Z1 minus Z2, fine, like in the ordering. Z minus Z1, Z1 minus Z2, then Z2 minus Z3, and for the last case is Z3 minus Z. Fine. So this is the way you can define the cross ratio, and it is denoted by Z, Z1, Z2, Z3. Make sure students, the ordering is a very careful. Like if you write the number is Z, Z1, Z2 and Z3, and second number you can write as Z, Z2, Z1 and Z3. Definitely they are not equal. Fine. So for example, if I take the 4 numbers 0, 1, iota and 2, and the second number is 0, iota, 1 and 2, definitely they are not equal. Fine. How you can define the number 0, 1, iota 2? So as I mentioned you can subtract the first 2 numbers 0 minus 1 and then 1 minus iota, then iota minus 2 and then 2 minus iota. So can you solve them? The numerator becomes, it's a minus 1, I can multiply them. It's a 2 minus iota divided by 2 minus 2 iota. Fine. So I can cross rationalize it. 2 minus over 2 plus 2 iota. Denominator becomes 4 minus 4 iota square. The numerator becomes 4 plus 4 iota minus 2 iota minus 2 iota square. It will be plus 6 plus 2 iota divided by 8. So you can cancel by 2. It's a 3 plus iota divided by 4. Fine. On the other hand, for the second case, I can write this number is 0 minus iota. Fine. 0 minus iota. Then next number is iota minus 1. Next number is 1 minus 2. And the last number is 2 minus 0. Now you can see it's a minus 1. It's a iota. It is my 2 iota minus 2. Now you can rationalize them. It's a minus of 2 iota plus 2 minus 2 iota. Always remember, when you rationalize them, you need to change the coefficient of the iota. In this case, it's a 2, so I can change as a minus 2. The numerator becomes minus 2 iota square plus 2 iota. The denominator becomes, sorry, it becomes minus of 2. Real component becomes the same. Fine. So this is my minus. It's a square minus b square. Fine. So it's a plus 2 minus 2 iota, 4 plus 4, 8. And now you can see it's a iota minus 1 minus iota divided by 4, which is not same as of the numbers. Therefore, the ordering of the cross ratio play a very significant role. Now we can extend the cross ratio to the extended complex plane. Extended complex plane means C infinity when some infinity points include. So again, the concept is very simple. If it is written as infinity, I can replace by the z and taken the limit is z approaches infinity. The written way is same, z minus z1, z1 minus z2 and so on. For example, can you evaluate the cross ratio? So let's say for the first part, if I use as 1 minus iota, 2 minus iota, 3 minus iota. How you can write that? First component minus second. Fine. Then 2 minus iota minus 3. Then 3 minus minus plus iota. And then minus iota minus 1 minus iota. Fine. Now you can simplify them. The numerator becomes minus 1 plus 2 iota and it's a 3 plus iota divided by minus 1 minus iota and minus 1 minus 2 iota. Now if you multiply them, the denominator becomes 1 plus 2 iota plus iota plus 2 iota square. This number is my minus of 2. So minus 1 plus 3 iota. Similarly, you can write for the numerator part. Now you can rationalize them. Minus 1 minus 3 iota minus 1 minus 3 iota. Now you can simplify them. Denominator is a square minus b square. And after the simplifications, you will get answer is 2 plus iota. Similarly for the second component, now it's my infinity. Fine. Then how you can write that? This number is my z. I can taken as a z approaches infinity. I can replace this number as a z. So how you can write the cross ratio? The first number 2 plus iota minus iota. Fine. First number minus second. Second minus third. Fine. Then third. Sorry. Iota 5 minus 2 iota. It's not a 5, it's a 5 minus, so minus minus plus. Fine. Then it's a 5 minus 2 iota and then I can written as a z and then it's a z minus 2 minus iota. Fine. Now how you can solve that? Again, this part is my 2 and this number is my minus 5 plus 3 iota into limit z approaches infinity of 5 minus 2 iota minus z divided by z minus 2 minus iota. Can you find the limit of this quantity? Now clearly say this number is my infinity by infinity form. I can apply the L'Hopital rule. So this quantity becomes minus 1 and plus 1. Fine. Now you can cross multiply them. After the simplification, you will get the answer as 5 plus 3 iota divided by 7. The part third, fourth and fifth, you can do it by own. You can try it yourself and let me know your answer in the comment box. Now, the first result related to the cross ratio is every bilinear transformation. Bilinear transformation is also known as Mobius transformations preserve the cross ratio, or you can say the cross ratio is invariant under the bilinear transformation. That means if you have the numbers, if you have the transformations, W is equal to T of Z, fine, such that T of Z is AZ plus B and CZ plus D is a bilinear transformations. So because we can define the cross ratio, we need the 4 points W1, W2, W3, W4. Corresponding to each Wi, we can define the point as a Zi, where I varies from 1, 2, 3 and 4. So can you find the value of the W1? W1 is T of Z1. That means A Z1 plus B divided by C Z1 plus D. Similarly, W2 is A Z2 plus B divided by C Z2 plus D, and so on. Fine. Now what is the meaning of the preservedness is? So your target is to prove the cross ratio of the transformation W1, W2, W3, W4, which is same as Z1, Z2, Z3, Z4. Fine. Or in other words, you can say the mapping T of Z1, T of Z2, T of Z3 and T of Z4, which is same as the first number is Z1, second is Z2, third is Z3, fourth is Z4. This is your target. Make sure students, the order matter. If you write as a Z1 firstly, then you have to write as a Z1 firstly here. You write Z3 as a third number, then it's a 3 is there. Fine. Now let's start with the how you can write on the left hand side, that is W1 minus W2. Second part you need it as a W2 minus W3. Then you need it as a W3 minus W4, and then you need it as a W4 minus W1. So I can try to compute W1 minus W2. So if you take A Z1 plus B over C Z1 plus D minus A Z2 plus B C Z2 plus D. Now if you take the LCM will be C Z1 plus D and C Z2 plus D. Now if you simplify them, this expression becomes AD minus BC into Z1 minus Z2. If you take the LCM, you can see AC Z1 Z2, AC Z1 Z2 will be cancelled out. Similarly, you can write as a W2 minus W3. What will happen in the new denominator? You can replace, it says CZ2 plus D, CZ3 plus D, and the numerator becomes AD minus BC. Instead of the Z1 minus Z2, now it becomes Z2 minus Z3. Similarly for the third case and the fourth case. Fine. Now let's start with the left hand side. How you can write the left hand side? W1 minus W2, W2 minus W3 and so on. I can substitute the values. That means I can multiply W1 minus W2. I can multiply this. So you can see the denominator becomes cancel out. Fine. AD minus BC will be cancelled out. The only expression which are left behind is Z1 minus Z2, Z3 minus Z4 and so on. So what is this number? I can write this number is Z1, Z2, Z3 and Z4, which is the cross ratio on the right hand side. Now we will consider some more examples how we can solve it. For example, find the bilinear transformation which maps z is equal to infinity iota 0 to the 0 iota infinity. Very simple. Fine. I will tell you the two different methods. Fine. The first method by using the cross ratio. First method by using the cross ratio, and the second method I can use by the definition of the Mobius transformations. Fine. So let's start with the firstly the cross ratio. How you can define the cross ratio of the four numbers between the Z and the W. Fine. W minus W1, W1 minus W2 and so on. So let's start with the first method. What is given to you? I can choose it as Z is infinity. Fine. Sorry, one is a Z. So I can choose in the four numbers. The Z1 is infinity. This is my Z1, this is Z2, this is Z3. This is the W1, W2, W3. Make sure order बिल्कुल maintain रखना आपको. This is the Z1, Z2, Z3. This is W1, W2, W3. Now I can substitute all the values in the given equations. So it will be, now it said firstly W1. So W minus W1, W2 minus W3. So I can take on W3 is my limit. Fine. Limit W3 approaches infinity. Then W1 minus W2, W3 minus W, which is equal to right hand side is Z minus Z1. Z1 is my infinity. On the right hand side, I can take on Z1 approaches infinity. Fine. Or you can write here is limit W3 approaches infinity, and here is limit Z1 approaches infinity. Now what will happen? You can see it's a limit W3 approaches infinity. This number is my W. This number is my minus iota. Fine. I can divide it the numerator and denominator by W3. Then it is a minus 1. So that because W3 is my infinity, fine. So it becomes a 0. Similarly, on the right hand side, because Z1 is my infinity, I can take Z1 approaches infinity. I can divide it Z1 in the numerator, divided Z1 in the denominator. Iota divided by Z1. This number is my iota. This number is my minus Z. Fine. Now you can substitute the limit. W3 approaches infinity. This value will be 0. This value will be 0. The numerator becomes minus 1. So that will be W upon iota. Similarly, this quantity will be 0. This quantity will be 0. It's a minus 1. Minus minus cancel. So can you find the value of the W? Iota square. Iota square will be my minus 1 over Z is the required answer of the problem. You can check your answer in the examination as well. When you substitute Z is equal to infinity, the answer will be 0. You can check when Z is equal to infinity, answer is 0. Look at the second case. When you substitute Z is equal to iota, W will be iota. You can see if I substitute Z is equal to iota, then minus 1 over iota. If you rationalize them, you can see it is my iota. Similarly, for the last case, when you substitute Z is equal to 0, W is my infinity is the correct answer. Second method, we can use with the help of the bilinear transformation. What is given to you? Z is equal to infinity. The corresponding value is my 0. Fine. So I can substitute here when W is 0, Z is infinity means you can take it as the limit. Z approaches infinity. AZ plus B over CZ plus D. What does it implies? It's an infinity by infinity form. I can apply the L'Hopital rule. So A over C is equal to 0. That implies A is equal to 0. Similarly, for the second, Z is equal to iota, W is equal to iota. I can substitute here. This number is iota. A is my 0 plus B divided by C of iota plus D. Fine. You can cross multiply them. Fine. You will get the similarly for the third case. From the first case, you will get A is equal to 0. From the last case, you will get D is equal to 0. I can substitute A and D in this equation. So iota is B over C iota. So that implies B is equal to C iota square, which implies B is equal to minus C. I can substitute all these values in the given equation. B is equal to minus C, C is my C, D is my 0. So again you can see the answer is W is equal to minus 1 over Z is the right answer. Look at the second example. They all are finites. So that means I can start with this. Again, I will discuss the two methods. What is given to you? W1, corresponding value of the Z1, 2. What is the value of the W1? 1. What is the value of the Z2? Z2 is my 0. Sorry, Z2 is my 1. Fine, this is my Z2. value of the W2 is my 0, and the value of the Z3 is my 0, value of the W3 is my iota. Fine. Now you can substitute one by one in the given equation. W minus W1 divided by W1 minus W2, W2 minus W3, and W3 minus W, which is equal to Z minus Z1, Z1 minus Z2, Z2 minus Z3, and Z3 minus Z. Fine. Now you can simplify it. What will happen? You can simplify it's a minus iota W, minus of iota, minus minus, it's a 1, then it's a iota minus W. This number numerator becomes Z minus 2, denominator becomes minus Z. Fine. Now you can cross multiply it. Your target is to find the value of W. Now you can cross multiply it. It's iota WZ minus iota Z, which is equal to iota Z minus 2 iota minus ZW minus minus plus 2W. Now you can take the coefficient of the Z on the left hand side, right hand side of the other terms. So that will be iota Z. Fine. This is the W. You can move on the right hand side, left hand side Z, and this is my minus 2. While on the right hand side is iota W minus 2 iota. This quantity becomes my plus iota Z. So therefore your W becomes, I can write W becomes, I can take iota is a 2 iota Z minus 2 iota divided by, I can take an Z is common, 1 plus iota minus 2 is the right answer of the problem. Fine. And you can check your answer as well. When you substitute Z is equal to 2, what will happen? Your answer must be 1. So we can see when Z is equal to 2, the numerator part becomes 4 iota minus 2 iota. When Z is equal to 2, it's a 2 plus 2 iota minus 2. Numerator becomes 2 iota over 2 iota, that is my 1. Similarly, when you substitute Z is equal to 1, the answer becomes the 0. And when you substitute 0, answer becomes iota. Second method is by using the transformations. That means when W1, when Z1 is equal to 2, W1 will be 1. Fine. So I can substitute one by one. W is equal to 1. Z is my 2. 2A plus B over 2C plus D. W2 is 0. Z is equal to 1. So A plus B over C plus D. W is equal to iota. Z is equal to 0. That is B over D. Fine. Now from this equation you can find the value of the B. B is equal to iota D. Fine. From this equation you can find the value of A is equal to minus of B. Fine. From this equation you can see 2C plus D is equal to 2A plus B. Now you can substitute the value of the A is equal to minus B. Then the left hand side becomes minus of B. 2C plus D. I can substitute the value of the B is iota D. So B is equal to iota D. So I can find the value of the C is, D is common, minus of D is common, 1 plus iota divided by 2. Fine. Now C is in terms of the D. Can you find A in terms of the D? A is also in terms of the D. B is also in terms of the D. So I have computed all those values in terms of the D. I can substitute in the given equations A into Z plus B. B is my iota into D. C is my minus 1 plus iota D over 2 into Z plus D. Now clearly say the D will be cancelled out. The answer becomes minus iota Z plus iota divided by minus 1 plus iota Z over 2 plus 1. You can take the LCM of the two and get the required same answer as by the method number 1. Fine. So this is a way you can use, any way you can find the Mobius transformations. So can you please let me know whether you can solve all these 6 problems in a very simple way? Let me know in the comment box if you have any doubt, or you can put your answers of these 6 questions in your comment box. I hope you can like and comment on this video. You can share this video with your other friends. I will solve another 10 plus examples in our next lectures to understand more and different kind of the problems. I hope you can share this video with your friends. Happy learning always. Best wishes. Thanks for the watch.